there's another great thing we want to share, which Dr. Rosen will talk about, and that's a wonderful collaboration with Southern California and India. And if you can just be brief, so that we can get plenty of questions.
All right, great. Well, thank you. Thank you for inviting me. I'm a little bit, I think, a fish out of water in this particular panel, but I do have some exciting news to show you about a mission called the NASA ISRO Synthetic Aperture Radar Mission, NISAR as we say, or NISAR. It's quite an amazing partnership. It's been over 10 years in the making. I think I first went to India in 2011 to start technical discussions. It wasn't until 2014 or thereabouts when President Obama and Prime Minister Modi had their first meeting together. They were looking for a major partnership to codify, and NISAR was that thing that they made into a reality. So it's a really quite wonderful story. And relevant to this panel, NISAR is designed to meet a number of science requirements in the area of climate, carbon monitoring, which is also related to climate, and natural catastrophes, which often are a result of climate change. So it's a very complex project, both scientifically, programmatically, and technologically. And rather than explaining that to you in detail, I thought I would show you with a video, which is a picture's worth 1,000 words. This has many pictures in it, so it's like 7 million words that I'm going to be showing you here. This is about the launch and deployment of a very complex space mission. It's the first of a kind. We drew it on paper and then built it in partnership with India. The launch vehicle is the GSLV-2 vehicle from India, and the spacecraft is provided by India, the spacecraft bus, and the instrument, which is this large octagonal structure you see here with the boom and reflector that's being deployed. Those are all provided by the US. So you can see everything here is custom built by the US and India specifically for this mission. And that has to be coordinated down to the last screw that goes into the hardware across the Pacific and 2 completely different time zones. So this is a 12-meter, 40-foot diameter reflector built in the US on a 9-meter boom, 2,600-kilogram satellite launched on that launch vehicle. And once it's in orbit, in a polar orbit, it will be making very regular measurements of all the land and ice-covered surfaces of the Earth. So just one quick video to show you the kinds of measurements we can make in an animation. This is a radar instrument, so it pulses energy and receives that energy back and then can interpret the reflectivity of the ground. We make this in image format. So as we fly along, we make an image, we come back 12 days later, make another image, and we can actually, using this radar technique, measure the motion of the ground down to centimeter precision in an image format. So we make essentially 3D movies of the changes of the Earth, changes due to earthquakes, volcanoes. In this particular case, we're measuring the subsidence of the Central Valley of California due to water withdrawal from the Central Valley. And you can see, highly exaggerated, of course, but it's around a meter, 0.7 meters per year of subsidence. Right now, because of all the rain, it's actually going back up again. But in general, the trend is downward. We also measure the ice sheets using the same measurement of displacement technique, which gives us a strong indication of what's happening with the climate. So this is my last slide, I promise. This is a major mission. We measure global biomass by measuring the reflectivity of the surface in image format every 12 days, twice actually, every 12 days. So we can track changes in forest cover, changes in agriculture, down to the acre kind of scale. So we can see these changes and relate it to the carbon cycle and climate change. We measure the ice sheets in Antarctica and Greenland completely, and not just their state, but how they're changing over time, which can feed into models of climate change. And then again, we can measure groundwater. You're actually going up and down. This is Los Angeles Basin, going up and down about this much every year, thanks to water being withdrawn and recharged every year. And we have a very wide host of applications that we can support with this beyond just these science objectives. Since it's a radar, it can see through clouds, and it can see both day and night. It has its own illumination source. So it provides these reliable measurements for monitoring all around the world. We're making global measurements. We have a specific focus in India and in the US, and it's been a really delightful partnership. I've been to India over 30 times now, and even though you can tell from my name I'm not Indian,
they give you honorary citizenship.
I've already been given honorary citizenship by my colleagues. So.
Yeah.
Thank you. Well, that's
So, again, I can be more controversial than Paul can. So, JPL is one of the most under-recognized assets we have in Southern California. Everything they work on is so miraculous, right? But this miraculous project would not have seen the light of day if it weren't for India.
That is true. That's what the enabling means
exactly.
in that title.
Yeah,
yes,
yeah.
Absolutely.
India is an equal partner in it, right? When you see the news, which will happen as soon as the American instrument gets fixed and sent back to India, this time India is ahead of the US, by the way. The Indian instrument is ready, right?